And finally, requirement 7 of example 2b asks us to estimate shipping expenses for a month when Mgrl sells 32,000 units and makes 1,750 shipments. So it's all well and good to have these estimates of fixed cost and variable cost per unit and all that good stuff. But the purpose of this is to predict future costs, not just to model what has happened in the past, but to actually make predictions about the future. So here we are, and we've got our we really have 4 different predictions of cost. We've got our shipping cost based on number of units that we got with a high-low method, shipping cost based on number of shipments with a high-low method, shipping cost based on number of units that we got with regression, and shipping cost based on shipments that we got with regression. So we've got 4 different choices. Which choice should we use to estimate shipping expenses for a month when Mgrl sells so many units and makes so many shipments? Well, we know that shipments is a better predictor than units sold. That's what we found out last time with our higher R squared. So the question is, should we use the shipments model with regression, or should we use a shipments model with the high-low? Well, one thing that we do need to take into account is that the high-low method only considered 2 of these data points, whereas the regression model includes all of the data points given. So we learn something about the relationship using all the data that we have available. That's what regression does. So if I've got a choice, not only do I know which model is a better model, which predictor is a better predictor, but I know which method of getting the model is a better method, I'm going to use regression. So what does my regression tell me? My regression tells me that I'm going to spend, my shipping cost is going to be $121.24 per shipment, and it's going to be about $31,122 per month. So if I put in my 121.24 per shipment, and my fixed cost is 31,122. Now in real life, I'd probably round these. I'd probably round it to $120 per shipment, $31,000 per month, or something like that, just because it's easier to work with rounded data. But for the sake of discussion, I'll leave these the same so you can follow where they came from. Once I've got these, all I have to do is plug in the amount of activity, multiply that by the cost per activity, add that to the fixed cost, and we'll have our prediction of total cost. Now you'll notice that I have both units and shipments data in requirement 7. That doesn't mean I have to use both of them in my predictive model. Remember that these are 2 separate independent models. Each of them is attempting to model shipping costs entirely on its own. So we don't have a combined model that uses both units sold and shipments. If you're going to use a multiple regression model, you can do that. That's not what we did. We used a simple single regression model. So the unit sold model should not include any data about shipments, and the shipments model should not include any data about units sold. It's only having to do with shipments. So since we have the number of shipments, we're going to ignore the units sold data. Our model is a model of cost based on shipments, not units sold. So I'm just going to plug in the 1,750 shipments times $121.24 per shipment. And I'm going to add to that the fixed cost per month. So my total variable cost is going to be 1,750 times 121.24, or $212,170. My fixed cost is going to be 31,122, and my predicted total cost is going to be the sum of these, or about $243,292. Now, is this reasonable? Does this prediction make sense? Well, let's take a look at some other predictions that or other past data, excuse me, not predictions, but past data. So we've got a 1,700 shipment month where we had cost of $255. We had a 1,700 shipment month where we had cost of $228. We had 1,800 shipment month where our cost was $238. And here we're at 1,750 for our month that we're predicting. We're right between our 1,700 and our 1,800. and 255, 228, 238, and here we are sort of right in the middle of those. So yeah, I think it does make sense. Is it going to be exactly 234, 243, 292? No, it's extremely unlikely to be exactly that number. But it should be within a few $1,000s of that number. And so this gives us a useful model to predict. And if I'm the manager in charge of the shipping department, I'm going to want to know how this prediction and how the budget was made, so I have an estimate of, or so I have an understanding of how the people above me, my supervisors, are going to hold me accountable. And if I'm the supervisor of the shipping department manager, I need to have an estimate of how these costs are going to be incurred, so I know what to hold the shipping manager accountable for. One of the things we can do with this is we can recognize that units sold is not a really good indicator of shipping costs. And so if we have a month where we have a particularly low number of units sold, but shipping costs are high, that doesn't necessarily mean the shipping manager did anything wrong. We need to look at number of shipments, not number of units sold. So this is the kind of thing we can do with mixed cost analysis. Shipping costs are a mixed cost. They've got a fixed and variable cost component. So in order to do anything with the mixed cost, we've got to break it into fixed and variable components, come up with our cost function or our cost equation, and then we can use that to predict cost. And our prediction of cost is something that we can use to hold people accountable, to make plans, and to keep from holding people accountable for things they can't control. Like, for example, the relationship between units sold and shipping cost is not something we should hold somebody accountable for because there's not a strong relationship there.